We're going to take a look at more problems that have to do with uniform electric fields. For example, this one. We're going to find the magnitude and direction of an electric field where an electron is perfectly suspended. So when I say perfectly suspended, there's a downward force on this. Gravity is acting downward. The force of gravity, which we all know equals mg. However, there's some force countering this, which allows it to stay suspended. So I know the direction of the electrical force must be upward in order to balance it out. And we've learned that the electrical force equals EQ. These two forces are going to be equal to each other for this to be perfectly suspended. Some values you need are on your sheet, and they include the charge of an electron, which is equal to 1.6 times 10 to the negative 19th coulomb, and the mass of an electron, which is equal to 9.1 times 10 to the negative 31 coulombs. Setting these two equal to each other, EQ equals MA. The electric field is what I'm looking for. The charge of an electron, by the way, the charge of an electron is obviously negative, but we don't use that in here. The mass of an electron, that should be in units of kilograms, times G, which is 9.8. Solving for E, I get 5.6 times 10 to the negative 11th newtons per coulomb. I still need to decide direction. My electric field must be oriented this way in order to exert a vertical force. If the electrical force is pushing the electron upward, it must be repelled from the bottom plate and attracted to the top plate. The sign convention for an electric field is away from positive and toward negative, so my E field must be directed downward.